This is AP Calculus AB. We're going to be reviewing the intermediate value theorem, extreme value theorem, Rolle's theorem, and the mean value theorem. Intermediate value theorem says there exists at least one value C, that's an x value, on AB such that f of c equals y, as long as f of x is continuous on this interval, and as long as y is less than the right endpoint and bigger than the left endpoint, or y is less than the right endpoint and bigger than the left endpoint. Here's what this means. Let's say we have some random curve, and this first point is A, let's just give it a number, 3, and this endpoint is B7. The intermediate value theorem says that if you pick any y value between 3 and 7, there has to be an x value that correlates to it here someplace. In other words, every number between 3 and 7 has to be accounted for. 3.1, 3.2, 4, 6.5, all those y values must exist on this curve. Pretty obvious, I think. Extreme value theorem, EVT, if you will. F of x has at least one absolute maximum and one absolute minimum on the interval from a to b, closed, if f of x is continuous on that function. I mean, I don't know what else to say other than what that says. I think that's pretty obvious. So whatever kind of curve that you have, as long as it's continuous, there has to be a highest point and a lowest point. The highest and lowest points can be any place in this. Could be on the ends, like specifically, this led to the candidates test. So they could be the endpoints, or they could be on any x value that was a critical value of the first derivative. Mean value theorem and Rolle's theorem. This is actually the main theorem here, the mean value theorem. Rolle's theorem is a specific example of it. The mean value theorem says, as long as your function is continuous and differentiable, continuous on the closed interval, differentiable on the open interval, there has to be at least one time where the instantaneous rate of change is equal to the average rate of change. Slope of the tangent line is equal to the slope of the secant line. So let's say that your curve looks something like this. So these are your endpoints. That's not a very good example. Let's say that your curve looked like this. If I drew a secant line that went through this, it would have a slope. The mean value theorem says there has to be another spot on here that would have a tangent line that is parallel to that secant line. They'd have the same slope. Rolle's theorem is a little more specific. It says that your endpoints are the same height. So if your endpoints are the same height, the average rate of change through this, the secant line, have a slope of 0. So it's saying there must be at least one place where the instantaneous rate of change has to be 0. So that's a quick review of those theorems, and then we're going to look at some specific examples.